Have you ever touched a metal railing on a cold day? It feels absolutely freezing. But then you touch a wooden bench right next to it, and it feels way warmer. Well, here's the thing. They're actually the exact same temperature. So, why do they feel so different? It's because our hands don't really measure temperature. They measure how fast heat is moving. And that metal railing? It just yanks heat out of your hand much faster than wood does. And that's exactly why we need to dig into what temperature really is and how we can measure it accurately.
So here's what we're going to cover. First, we'll see if we can even trust our own senses. Then we'll get into what temperature actually is, scientifically speaking. After that, we'll check out the tools we use to measure it, learn the different languages of temperature, and finally, see why all of this is so important in our everyday world. All right, first up, let's talk about the most basic tool we have for judging temperature, our own sense of touch. But as we're about to find out, our bodies can be, well, pretty terrible at telling the truth. I mean, it seems like a pretty straightforward question, right? You touch something, you know if it's hot or cold. But is that feeling you get an objective fact, or is it just, well, a feeling? Let's actually put that to the test with a really simple experiment you can even try at home. Okay, imagine this. You've got 3 bowls of water. The one on the left is warm, and the one on the right is ice cold. You're going to put one hand in the warm water and the other hand in the cold water, and you just leave them there for about a minute. So far, so simple. Now here comes the twist. You take both hands out at the same time and plunge them right into that middle bowl, which is just filled with regular room temperature tap water. What do you think is going to happen? What is each hand going to feel? And this is what's so wild. The hand that was just in warm water, it thinks the tap water is cold, but the hand that was in the ice water feels that the exact same tap water is warm. This proves it. Our sense of touch is totally relative. We just can't rely on it for an accurate measurement. So, if we can't trust our own hands, what can we trust? This is where science steps in to give us a clear, reliable answer, removing from a feeling to a fact. And this is the key right here. Temperature isn't a feeling, it's a measurement. It's an objective, dependable way to put a number on how hot or cold something is. A hotter object simply has a higher temperature than a colder one. No confusion, no trickery, just data. And to get that reliable, objective number, we need a special tool. That tool is, of course, the thermometer. It's designed to completely bypass our flawed senses and give us a piece of hard data, not just a vague feeling. Okay, so we need a thermometer. That's clear. But, not all thermometers are created equal. Let's take a look at 2 of the most common types you'll run into. On the one hand, you've got the clinical thermometer. This one is specifically designed for taking a person's temperature. Notice its range is super narrow, just from about 35 to 42 degrees Celsius, because our bodies don't really stray outside of that. But then you have the laboratory thermometer, which has this huge range from -10 all the way up to 110 Celsius, making it perfect for all kinds of science experiments. Now, having the right tool is only half the battle. You have to use it correctly. And some of these tips might sound obvious, but they're crucial. Things like washing the tip, keeping the display dry, and this one's a big one, not holding it by the sensor tip. Otherwise, you might just be measuring the temperature of your own hand. And check this out. This shows a really common mistake people make with the lab thermometers. To get the temperature of a liquid, the bulb of the thermometer has to be completely surrounded by it, but it cannot be touching the bottom or sides of the glass. If it is, you might be measuring the temperature of the beaker instead of the actual liquid inside. So, we've got the right tool, and we know the right way to use it. But what do the numbers it gives us actually mean? Well, that all depends on which language of temperature you're speaking. So there are really 3 main players. You've got Celsius, which is the standard for pretty much the whole world for things like the daily weather. Then there's Fahrenheit, which is still commonly used in a few countries, like the United States. And finally, you have Kelvin. That's the official unit for science, and it's special for a reason we'll get to later. So when a doctor in, say, France or Japan says your temperature is normal, this is the number they're thinking of, 37 degrees Celsius. But a doctor in the US would use a totally different number to describe that exact same amount of heat, 98.6 degrees Fahrenheit. It's a perfect example of 2 different scales talking about the very same physical reality. Oh, and here's a quick fun fact. You might remember those old glass thermometers from when you were a kid. Well, the reason we switched over to digital ones isn't just because they're easier to read. It's because the old ones were filled with mercury, which is super toxic stuff. Breaking one was actually a pretty big deal. Okay, so we've covered the what and the how. But let's zoom out for a second and talk about the why. Why is getting this one measurement right so incredibly important?
Well, the truth is, its impact is everywhere. We use it to monitor our own health, obviously, but it's also the absolute foundation of every single weather forecast you've ever seen. It tells us everything from whether we need to grab a jacket to when a major storm is coming.
This quote from the incredible Indian physicist and meteorologist Anna Mani just says it all. Wrong measurements are worse than no measurements at all. Think about it. If your starting data is wrong, every single conclusion you make based on that data is also going to be wrong. In science, getting it right is everything.
And this is what that looks like in the real world. All across the globe, at thousands of weather stations, scientists are constantly taking the temperature of the air. All of that data gets fed into giant computer models that help predict our weather.
Now, get ready for a pretty mind-bending idea. It turns out there's a limit to how cold things can get. There is a cosmic speed limit for cold, a temperature floor. It's called absolute zero, or zero on the Kelvin scale. That's minus 273.15 degrees Celsius. You physically cannot get any colder than that. And so that leaves us with one final fascinating question to chew on. We know there's an absolute bottom to the temperature scale. But what about the top? Is there a such thing as absolute hot? Is there a limit to how hot something can possibly get? Now that's something to think about.